Hello everyone and welcome to the Reigning Grades Kingdom. My name is Elle and today is all about balancing redox reactions. But before we get into the video, make sure you go downstairs and click that like button, and also don't forget to subscribe so you can be notified whenever I post new videos. So without further ado, let's make it boom. Well, first, to balance a redox reaction, we have to know what a redox reaction is. So what is a redox reaction? In order to have a redox reaction, you have to have a reduction reaction and an oxidation reaction happening at the same time. Of course, you can't have reduction without oxidation, so that works out. You should definitely find where your transfer of electrons are to see which part is oxidized and which part is reduced. And with that, we're on to balancing redox reactions, or as I like to call it, the jigsaw puzzle of chemistry. Now, the first and easiest way to do this is by inspection, and of course our goal is to make sure you have the same amount of elements on both sides of the arrow. So to do this, we'll count up the number of carbons, hydrogens, and oxygens. As you can see, we're lacking hydrogens on the right side and oxygens on the left side. So what we have to do is strategically add numbers in front of the molecules until the elements on the left side equal the elements on the right side. By adding another water molecule, you're able to double the hydrogen, and then the only thing you need to balance out is the oxygen. And now that we know that, let's get on to balancing some harder redox reactions. Step number 1, split your equation up into the reduction and the oxidation. If you need a refresher on what reduction is as opposed to oxidation, feel free to watch my video on oxidation numbers. But for right now, I'll assume that you know, and let's split it up into our two half reactions. So our first half reaction is the sulfur trioxide turning into sulfate, and our next one is our hydrogen peroxide going to water. Step 2, balance them on their own. We'll start by balancing all the elements that are not hydrogen or oxygen, and since that's only sulfur and it's already balanced, our next step depends on if the reaction's in an acidic, basic, or neutral environment. Wait, acids and bases? This is so complicated. But it doesn't have to be. You see, we'll add some water to the oxygen deficient side, and since we ended up adding some hydrogen, we'll add some hydronium because this is occurring in a neutral solution. Then in order to balance it out again, we'll have to add some more water back to the other side, and then we'll do the same for the second equation. If you're in an acidic solution, add your hydronium, but if you're in a basic solution, add your hydroxide. Next, you have to balance your charge. And this step is super easy because it's just addition and subtraction. So as you can see in the first equation, you have a 2 lesser charge on the left side, so we'll add 2 electrons to the right side, and vice versa for the second equation. Next, balance both sides of the equation, meaning cancel out redundant components. So anything that's the same on either side of the reaction, you can cross it out. This is definitely my favorite part because the less chemistry, the better. Now we can add them together, and we're almost done. So as you can see, our resulting equation is almost identical to the original, just with an extra water. And that's how you balance a complicated redox reaction. Now let's try a similar example, except this one will take place in a basic solution. So we still split it up into two half reactions, and we add water to the oxygen deficient side, but now instead of adding hydronium, we're going to be adding a hydroxide group. Then we're going to add some water and balance that equation, then balance the charge, then we're going to work on the second equation. But as you'll notice, there are a different number of electrons transferred, and you can only add 2 equations when the electron transfer is the same. So what do we do? Just use multiplication. Okay, so since our least common multiple of 2 and 3 is 6, we'll multiply the entire top by 3 and the entire bottom by 2. Then we'll be able to cross out all the redundancies, add them together, and end up with our final equation. For these next practice problems, I encourage you to write down the equation and pause the video and only resume when you have your answer. Are you ready? Alright, here's your first problem. Make sure you split it into 2 half reactions. Then I'm going to balance it very quickly on the screen for you here, so you are left with your final answer. Now, problem number 2. Here's your problem. I'll balance it super quickly, and there's your answer. Of course, if you didn't know, this is the equation that occurs to make rocket fuel, so chemistry can be fun, you just gotta stick with it. Thank you so much for watching this video. I hope that I helped you get an A on your test. Much love always from Elle, and I'll see you again soon in the kingdom.
It's good to be alive right about now.
Next, you have to balance your charge. That was the dumbest thing I've ever. Step 2. Balance them on their own. Oh my gosh. Princess Diary is a true story based off of my life, so... If it's in an acidic solution, you should... That was hard.